before I start, I'd like to quickly give you a background about the presentation. So I will start off the presentation with talking about the importance of analytics and visualization in safety analyst and what are the different components we have. Then Marsha will take the floor and she will talk about the strategic objectives and vision and mission for West Virginia. And the last presentation will be by Uday. He will go over a case study using the Roadway Departure crash for West Virginia. And he will show demo a summit presentation. So just start off my presentation with a quick visualization overview. The first question we have in mind, why the data analytics and visualization is so important for safety. So there are different reasons for that. The first thing is that we have a big network to analyze. And how big is the network? We have roughly 4.09 million miles of roadway in the country. And on this mile of road, we have roughly 6.3 million crashes per year. That is the statistics from 2015. So if you put these two things together, we have in every mile of road, we have 1.54 crashes per year, right? So huge network and a lot of crashes. So we definitely need a way to identify the locations where we can spend the money to get the best benefit. So for that, analytics is so important. The second thing is we have a big and diverse network to analyze, big and diverse variables to analyze. And what are those variables? We have a guide from Federal Highway, that MMUCC, Model Minimum Uniform Crash Criteria. And it prescribes there are 115 different elements that you need to analyze if you want to understand the different elements of the crash. So for each of the crash report, these are the prescribed number of variables you should collect. So think about this picture, a lot of crash and a lot of variability. So we need to have a technique or analytics and visualization so we can pinpoint the issues with crash and make your best decision. Third thing, we have to make a precise investment decision. So you cannot say that I want to fix all my 4.03 million miles of roadway. It will be like trillions of dollars you have to invest, right? So you cannot make that decision. So we have to come up with a precise investment decision. And how we can do that? We have some guidelines from FRED. One of the thing is we have HSIP funding bucket, which is Highway Safety Improvement Program. And these are the different funding bucket from the FAST Act for each of the state. And FAST Act said that you have to have a data-driven analytics or comprehensive solution that will lead you to a strategic highway safety plan. So if you want to come up with, okay, what are my focus area for the state and how I should spend the money, you need to rely on the analytics to find out your focus area, your strategic objective, and from there you start spending the money. So that's why it's so important, the analytics and visualization in safety. We have to be proactive rather than reactive. We cannot wait until all my system are falling apart. We're not investing anything. So from that perspective, we need to have some predictive capability so we know what are the condition of the road, and from that we spend our money and become proactive. So even though there is no crash on a stretch of roadway, we can try to improve the condition of the road and try to identify any geometric deficiencies so that we become proactive and can save a lot of money. And from that perspective, a lot of the asset management analytics that we use in our world, like for example, the deterioration model and other different predictive capability, those all take a part in identifying those proactive conditions. We also need to reduce that data clutter. So we don't want to deal with everything, all these data elements, and try to find out the solution. We have to have a systemic way to identify what are the focal point. So that's why it's so important. And lastly, we need to learn from the past. So you know that in safety analytics, we use something called the crash reduction factor, which is if I implement a countermeasures today, what are the benefits that I'm having? So we need to look at the historical data of all the implementation that we are doing for in terms of reducing the crash, and need to learn from that perspective and need to spend money based on that decision. So we always need to learn from the past. Now I'd like to quickly go over the data analytics overview that we have. The first thing we have is the predictive analytics. So predictive analytics means we want to really predict what will happen with all these underlying conditions. And in And so to find out a causal relationship with different factors and the outcome of that. And in predictive analytics, we have basically two different types of models. We have traditional model. We have the frequency model that deals with the number of crashes that are happening, and the other one is the severity model. In frequency model, generally we have two different things. We have the fixed parameter model. So most of the safety performance function that we have, we use fixed parameter model, and it has a negative binomial distribution. And we also have something called random parameter model. So I can give you an example that if you fit a model in Texas, you cannot say that this model will be applicable for every county in the Texas, because there are different diverse patterns, there are different other weather conditions. So your developed parameter that you are developing, the parameter can vary from region to region. So that's why there is one concept that we randomize the parameter, and we bring some of the probabilistic distribution to the parameter itself. And we call it random parameter model. We also have severity model, and the severity model is basically kind of a choice model. You know that if there is an accident, there can be different outcome for that. There can be fatality, different types of injury, and there can be property damage only. There are different types of category. So in order to understand that if there is a car, for example, and you know there are different safety features to the car, and it involved in a crash, using the severity model, you might be able to predict what will be the outcome of that accident, whether how many people can get killed, how many people can get injury. And this severity model has a lot of impact, how we make decisions on safety features, how we make decisions on any funding related to geometric features. So all the decisions we can make on the severity model. And I think one of the, we know that the helmet law for motorcycle crashes, actually that was an outcome of a severity model, that we were able to predict that if you don't use helmet, this is the percentage of fatalities happening, and we were able to prove that by a severity model. And that's how that some of the laws for helmet law or some of the cell phone related crashes, and we are having cell phone banning, those things are coming from the severity model. So this has a very high impact on the overall safety analytics. We also have the recent trend of using machine learning and decision trees in trying to identify and predict the crash causality. One example is in using machine learning, you can develop an artificial neural network and have your system understand the different variables and try to predict what should be the outcome from that. And there are several studies that actually compare between the machine learning techniques and the traditional negative binomial model, and we often find that machine learning actually have better predictive capability. Similarly, decision tree is another aspect of analytics. Like you do not rely only on the traditional, for example, in safety performance function, we have traffic count as a predictor for the crash. Using decision tree, you can plug in other variables. So you can consider some of the demographics and some other features that can be considered the surrogate of your exposure. And using that, you can come up with a better model, better predictive capability. The next thing, we have the exploratory analytics. In the exploratory analytics, we basically, okay, before I go into the exploratory, there's a quick overview about our framework, how we implemented the predictive analytics in our software. We maintain crash filter when you do a network screening. And using that crash filter, we also have the established safety performance function, which is this one, maintain SPF. And when you run the network screening, basically it considers the roadway departure and different types of safety performance function. It adjusts those functions by empirical based technique, which is kind of learning, which is a quasi machine learning kind of thing, that you actually incorporate some of your actual crash counts and adjust your model. And based on that, then we identify the level of service of safety. And then you identify the hotspot. And this framework has been implemented in Montana. That's the same framework we are using. The next thing is the exploratory analytics. So basically, you are trying to identify, we have a lot of variables in our crash records. We want to identify what are the best way we will be able to find out the root cause of any problem. So there's an example that, for example, you are trying to find out the crashes that are happening due to road departure crash. You can start from your crash data, and you can start building your your hierarchical query on top of that. You can say, okay, my crashes can happen, and the reason I'm trying to investigate is due to the rollover crash, right? Your first filter is a rollover crash. Then you deep down and you find out, okay, I have the grade condition and the curvature condition. I can consider those. And using the grade condition, I have 3 different types of grade. We have level terrain, rolling terrain, mountainous terrain. And on top of that, you can consider some of the behavioral factors, like whether the driver was using cell phone or not. So you can build very complex query and try to find out what are the root cause for that. And this kind of complex query we can easily demonstrate if we use some better analytics tool. And we have something called Summit. And Uday will show you the demonstration for that. How using Summit we can explore the data and can find out the root cause of an accident or root cause of a group of accident, and can make best decision from there. The last thing I would like to highlight is the spatial analytics. So if we have our distribution of the crash, there is always a relationship, right? Because your same pattern of the crash, if it's happening at the same location, there might be an underlying reason for that. So we want to see everything on a spatially and try to find out what's happening there. One of the example is by doing this kind of heat map. And we can do this by using ArcGIS Online. Since we have this connection to the ArcGIS, we can export the map and render that and use some of the SD capability to find out, to create this kind of heat map. And this kind of heat map will be useful for you. For example, you are trying to locate your cell phone banning zone, right? So you put all your distraction driving crash in the map and generate some kind of heat map. So all these, the yellow and the red dots, those are actually the kind of the boundary, the lot of distracted driving crash. And you can focus on that, and you can probably impose some kind of banning in that area. And then you can make a better decision from there. So that spatial analytics, since we have the Esri integration, it's very easy to do that. So our software at all these Oracle Spatial can talk to the ArcGIS server, and then we can use the ArcGIS Online tool. We can use collectors and other features to spatially show our distribution of crash, and definitely can get a better results from there. So this is in short the visualization framework, how it looks like. We have the predictive analytics, the exploratory analytics, and spatial analytics. And we have 3 different frameworks for that. We have the Summit, we have ArcGIS Online, and we have the Jasper server, which is a new tool. So using all of these features, we can definitely make a better decision. So with that, I would like to transfer the control to Marsha, and she will talk about the highway safety focus area in West Virginia. Thanks.
Thank you. Okay, so we're going to shift gears a little bit, and I'm not going to talk to you so much today about the system as kind of why we need the system and why we use the system. Focus on highway safety in West Virginia. All right, so West Virginia is a small state, but we have the 6th largest roadway system in the United States. That's largely because we're one of 4 states in the country that maintain the bulk of all of our roads. There are very few municipal streets, and all of our local roads are actually under the state highway system. So the state maintains 93% of the state's roads. Okay. So in West Virginia each year, we average about 300 fatalities on our roads and highways. That's a lot of people to die in a small state. And while those numbers have came down over the past several years, we still consistently kill quite a few people there, and are trying to make it safer. You know, there's no one in this room that if I ask you who in your family would it be okay to lose that would volunteer and say, oh, I'll give up somebody. So we don't like to see those numbers. We want to see them come down. So why do we focus on highway safety? There's clearly the lives and the injuries, but FHWA, who I like to pick on, also gives us lots of reasons to focus. As Shafiul mentioned, the FAST Act has increased a lot of funding towards the Highway Safety Improvement Program. West Virginia, when I first started working for them, had less than $5 million annually in all of our HSIP funds combined. We now are looking at $28 million a year. That's quite a bit of increase, especially when you haven't gotten any more people to work on. In fact, we have less. So they've also required us all to develop a strategic highway safety plan. They've set out safety performance measures that cut across the hard side as well as the soft side of safety and things that they expect us to look at. And then they've developed this lovely program for focus states. So today I'm going to talk to you a little bit about our strategic highway safety plan and focus states. So we've just recently revised our SHSP at the end of 2017. We reaffirmed our vision of 0 fatalities. We used the tagline of saving one life at a time. You all probably noticed a little bit of my propaganda that appears sometimes in my slideshow there with our little logo. But kind of like I said a minute ago, it seems like when you say 0 fatalities that like you think initially that's not realistic, that somebody's going to die on our highways. But as I said, who is going to volunteer to be that person or to give up a family member or a friend? I know I'm not. So we've set an interim goal to reduce our fatalities by 50% by 2030 and to reduce our serious injuries by even larger percentage of 66. So we use the system like Agile system and some of our other tools to help us to identify the areas that we need to focus on. And when you all look at this, it really quickly pops out to you that West Virginia has a roadway departure crash problem. They account for 50% of our serious injuries and 66% of our fatalities. If you've ever been to West Virginia, you would understand how easy it is to leave the road. We've got lots of windy little mountain roads with very little to no shoulder. Quite often you're looking at a rock face on one side and the cliff on the other. There's lots of trees there to hit. There's lots of things there. And you can see that we also have some alcohol and drug-related crash problems. Have lots of people that don't want to wear their seat belts, put their kids in child passenger safety seats, or wear a helmet when they're riding their motorcycle or their ATV that we allow on our roads in West Virginia. So those are our main focus areas, with our biggest one being roadway departure crashes. So what is a roadway departure crash? FHWA has defined roadway departure crash as being a single vehicle, non-pedestrian, non-bicycle crash that results in a hit fixed object. Head-on crashes and sideswipe opposite direction crashes can also count. And other multi-vehicle crashes in which a fixed object is the first harmful event in the crash. Intersection crashes do not count as roadway departure crashes. So when we look at roadway departure crashes in West Virginia, obviously when you leave the road to the right or the left, that's going to qualify you really quick. But as you look down through there, you can very quickly see the kinds of fixed objects that folks are encountering as they leave the road. So trees, lots of embankments, lots of guardrail and barriers. We've got ditches. We've got utility poles that are basically sitting right beside the road. So FHWA, in another effort to help states, has developed some focused state programs, and they've got 3 of those going on right now. And the goal of these programs is to help states to better address critical safety challenges, to help them to target the delivery of their highway safety programs towards their major safety issues that they have, and to provide some additional support to the states that are struggling in some of these areas. So they've got 3 areas right now: roadway departure, which accounts for 53% of all highway deaths nationally, intersection-related crashes, and pedestrian crashes. Fortunately for West Virginia, intersection-related crashes and pedestrian crashes are not a significant issue for our state, but roadway departure crashes are. So FHWA, to determine who could be a focus state, utilizes 3 years of data, and they calculated the expected roadway departure fatality rate under 3 categories. They use a percentage of urban and rural VMT, your population, and centerline miles of road. Then they compare those rates to national percentages and fatality rates, and if your actual versus expected ratio is higher than 1.0 for all 3 of those, then you qualify to be a focus state for roadway departure. West Virginia qualified quite easily. So, as a part of their program, they're helping us to write a plan to address roadway crashes. And the idea is to focus our countermeasures on keeping vehicles on the road, helping them to have a safe recovery if they do manage to leave the road, and if they can't get back on the road, to reduce the severity of whatever happens when they're off the road. So keeping the vehicle on the road involves things like improving signings and markings for curves, center and edge line rumble strips, better delineating the alignment, high friction surface treatments. We're actually doing a lot of those in West Virginia right now, and we're seeing a lot of really good results from that. And then we also work with our enforcement and education partners to address certain areas and help with some of those issues as well. Under safe recovery, we're trying to provide wider shoulders. We're utilizing a lot of safety edge on our paving jobs, and if you're not familiar with that, safety edge is sort of a wedge that's added to the edge of the pavement. There's a special shoe put on the paver, and it basically allows a vehicle to more easily climb back up onto the road without catching their wheel on the road and ultimately causing a rollover and things like that. So we're seeing a lot of success since we've implemented utilizing that. Reducing the severity, we've focused a lot on upgrading our guardrail, removing trees from our right-of-way. We haven't gotten too much into utility pole relocation yet, but we're starting to look at that. And we've got a lot of cable median guardrail on our freeways to try to prevent median crossovers. And we're increasing that each year. So we're going to talk a little bit about the different methods that we can utilize to reduce roadway departure fatalities. So we'll start with traditional. Traditional, they usually provide, they're highly effective, but you see a minimal statewide impact. A lot of the time, the traditional method of addressing roadway departure crashes is focusing on an area that has a high number of crashes, and it's quite often a high-cost solution. Things like curve reconstruction or even the shoulder widening. It required individual section analysis, and quite often you saw fewer than 100 improvements a year. You see a substantial reduction in fatalities and injuries at that specific site, but when you look at the overall picture, you didn't really see a substantial improvement statewide each year. Systemic improvements are basically the reverse to the traditional approach. You start with countermeasures that are effective, but they're often low cost. You find sections of roadway that have moderate to high levels of the targeted crash types, and you systemically install these improvements throughout those locations. You don't just focus on your high areas, you focus on what the problem is and or the potential problem is there. You look for an overrepresentation, generally 3 to 5% of the mileage with 25 to 40% of the statewide problem. And when you do these systemic improvements, you quite often see an overall statewide improvement with a reduction in fatalities instead of just a smaller reduction in one location. And then comprehensive. This just involves incorporating our enforcement and education. Again, we're focusing on areas that have high numbers of roadway departure, severe crashes, and we coordinate the efforts of engineering, education, and enforcement. We pick routes that any of the areas that I showed you earlier where you have alcohol-related crashes, those very easily can overlap into our roadway departure problems. So by working with our enforcement agencies, we're able to focus on those problems and keep our impaired drivers from leaving our road. So kind of combining those two things together, we're able to see a bigger effort that way. So, okay, and now Uday is going to give you all an example of how you can utilize the system.
So I'm going to change the gears again. We are going to talk a little bit of data visualization. And then we are going to take roadway departures crashes from West Virginia as an example and see how we can provide insights. So have you heard this quote before? When people used to travel via boats all over the oceans, they used to say, water, water everywhere, not a single drop to drink. You know what is equivalent to our day-to-day lives today? It's pretty much, we have data everywhere, not a thought to think. Isn't that so? We have so much data, and when Shafiul and Marsha were talking about, just safety has 115 elements to collect. And with that data, you have to have insights, otherwise that data is meaningless. It's the same for payment or for any other thing. So that's why data visualization is so important to us. So we have a pop-up quiz right now. So I'm going to show two pictures. Everyone should take out a pen and paper and say which one is safer. So if you have these two pictures, which one you think is safer? Which one would you prefer to drive maybe? The one with the signage, right? So what we are doing is, this is a low-cost treatment which we applied by adding signage. All we are doing is making sure people know and they are educated that the roads are safer, or this is where you need to slow down. So that's one of the improvements which we are doing as an engineering solution. So that brings up to the topic of the 4 E's. How we look at safety is, there are 4 E's which will solve any problem. The first one is engineering. Engineering, it can be as good as realigning your entire highway, or as simple as you are adding the signage. So as a safety engineer, you make the calls what needs to be done. You have the data with you. The second one is education. We have seen a lot of distracted driving crashes in Montana. And when we look at the focus groups, maybe the younger generation is more related to those crashes. So we have to have some education programs in our high school saying that distracted driving causes these issues. So make sure we are not doing those. And then enforcement. As Marsha was talking about alcohol-related crashes, having enforcement in those areas will always improve or reduction in crashes. And finally, EMS. EMS is the area where we are not preventing the crash, we are making sure the people are still alive. So that's a bigger impact and less loss to the family. So with that said, we'll go to AgileAssets Summit. So when you look at this, people always say it's a dashboard. But when I look at this, I don't say it as a dashboard, it is a data storyboard. Because when you look at the data, it is telling you some story. And if I have to pull up just one of these, the 3 years of crash data, which one would you say has a lot of crashes? The middle one, right? 2015. If you're looking at 2014, 15, and 16. Apparently, this is not our funding budget where we want the funds to be increased. It is crash data. So we want the crashes to be reduced. A similar example is when we look at our crashes when you segregate via highway class. Right now I'm looking at only 4. You see that county crashes have more number of roadway departure crashes. And the reason being, our interstates are engineered better. They are larger curve radius, more number of guardrails, better lighting, and so on and so forth, which we can't have on all our county route system. So that's why you see county route system has more number of crashes. And if I'm going into the details, let's look at the definition of what Marsha provided, which is roadway departure crash. We're looking at single vehicle. So I'm looking at single vehicle crashes. And now I want to look at all my counties. I'm saying that Kanawha County has the highest number of crashes. So to give you a brief background of Kanawha County is the most populous county in West Virginia, and the capital city Charleston is located in this county. And if I want to look at more details, I can see that the number of crashes between the age group 18 to 23 are more. So this indicates that if I want to do an education related programs in Kanawha County, I need to target the group 18 to 23, which may not be the case at somewhere else. So if I start my education program, we should look at high schools in Kanawha County and make sure they are more educated. So that's one story I'm looking at. The story, as I said, the story can be different. So if I'm looking at something else, let's say alcohol, driving under the influence, and looking at the same county graph, you can see the county change. It is Berkeley County right now. So if I'm looking at Berkeley County, the age group is different, 30 to 35. Berkeley County is actually located on the northeastern panhandle of West Virginia, and it actually connects two other states. And Highway 81 or Interstate 81 connects these two. So maybe there is a lot of drug trafficking going on there. So this is where I'm talking about enforcement programs to reduce the number of crashes. So you can do this type of visualization, and your storyboard already exists. So once that is there, as you are seeing, it's a click of a button, you have an insight to your data. So having said that, I would like to conclude saying that we should say data everywhere. You need to visualize for insights. Thank you. Any questions, please?